Go. Hi guys. My research topic is welding repair in Dragline buckets. Now, considering Australia as a landmass, the mining industries in Australia is vast and very vast. The Australian landmass has lot of mineral ores which can be exported to other parts of the world and can be used for manufacturing and other activities. Now, the value of this industry is about 120 million in total. Now, if we consider the graph and the if we gradual increase in 1990, the value of the industry was about only 60 million. On a gradual increase over years in 2002, it had it had a value of about 100 million in total. Now, what happened during this period was the manufacturing industries in Australia got shut down and they had a step where they was stagnant for about till the year 2005. Then they started to export these mineral ores to other parts of the country, and the market boomed for them. Now considering the Australian territory, in Northern Territory, the entire Northern Territory's production, 23% of the production is from mining. Now, if you go to consider Western Australia, it is 21% of the entire production is mining. Now, even if you consider Queensland, the mining industries produces about 9% of their total income. So now you can see that it's a massive and a huge industry in Australia. So what happened was the fall in, as I discussed, the fall in manufacturing. During this period, there was no manufacturing done in Australia, and it led to rise in export, and that's how they increased to 120 million in total. Now, considering my topic, that is dragline bucket. Now let us consider what a bucket is. Now, dragline bucket looks somewhat similar to like this. So what happens in ores are there are like the waste soil and the mineral ore are being combined together and being removed. So they are first separated by operators and laborers, and after they are separated, the waste needs to be taken from the ore to some other location. So these buckets are used for digging the soil with the help of these teeth, and it is transferred from one location to another. Now, how this is operated is like, let's see the setup. Now, in this diagram, this is a locomotive which handles the dragline bucket over there. So there is a boom which controls the dragline with the help of set of chains and ropes. So there are these buckets are joined to the locomotive with certain points. Now certain points are these points and the points above. So the hoist coupler is used to pull the dragline upwards. What the drag coupler does is to pull it towards the locomotive or away from the locomotive. So and this is operated by an operator which sits inside this locomotive and does all the work. Now, this industry is a 24-hour and 7 days working industry. They work continuously and without any stop or holidays. And also, it is a 365 days working a year. So this is a massive industry where production and durability is at the peak. So the rate of productivity of these buckets, these industry is so that like the equipment have to be well maintained and well inspected properly, and had to have a proper working this. The weight, now for that, the weight capacity. Now the soil which is being excavated are like in tons. So as you can see, the buckets which was shown in previous slide has the size of the bucket is about the size of a man. So it is a huge thing, and the soil which is removed is in tons. So the weight is more. The integrity, now as the weight increases, the structure which is holding the soil, the bucket metal has to withstand those loading. So integrity is a part of it. Now durability, as I said, it's a 365 days working industries. It needs durability. Without durability, if there is some damage or critical fatigue, it needs to be solved, and it can't be. It is very highly costly for the industry to have such incidents happening. Now going to productivity. Now what is like to increase to discuss productivity? Let's talk about the bucket cycle. Now this overburden from the mine to the waste bed, there is a process which is followed. So now let us consider that. Now the first process is scooping. Now what is scooping is like digging of the mineral from the ore and the digging of the process, the digging of the waste material is called scooping. Now consider swing. After this pickup, the bucket is swinged from one place to another. That is from mine to the waste bin. Now after that, dumping. Now wherein the bucket dumps the waste into the waste bin. Now going further is swing back. Now after the dumping process, it has to continue the process. So it has to come back to the mine. So it just has to swing around again to the mine. So that is swinging again. Now the materials of this bucket is a major concern. Like the weight of the buckets cannot increase so much so that the bucket cycle will be affected. So what is the problem is when it is heavy, it takes more force for these couplers to pull them, and it is a slow process to do this. Now suppose if it's lighter, what happens when it's lighter is like lot of tons of loads are being applied to this, so that this material will have early fatigue. Now this early fatigue will cause to lot of damages, which is not acceptable for this industry. Now that's like as I discussed, but bucket fatigue, if it's less, if the material is less in what do you say, weight. The ideal timing. The ideal timing is when these buckets are idle. So what happens when there is a fatigue or something is my industry, the bucket operations is not taken care of. This costs the industry a lot. It's like they work 365 days, so they need to produce that much bucket durability. Now coming to the repairs, the only option with the industry is to repair these buckets and have them brought to work immediately in a short span. Now what is the one point is addition of a wear resistance plate. Now what's a wear resistance plate is that in the bottom of these buckets a metal plate is being bolted or being welded. Now what happens to this is like it increases the weight of the bucket, which again reduces the productivity time. So which is also like increases the cost, which is not affordable by this industry. Now welding repairs. Now what can be done is during fatigues, welding repairs can be done, which would be further discussed in slides ahead. The other is to replace the teats. The excavating the buckets, the first impact is taken by the teats. As they dig the soil, they may come in contact with minerals, metal ores because of improper separation by the laborers and stuff. So they needs to be replaced. But still the part which is in impact or in contact, they have abrasive wears, which will be further discussed in slides. Now welding repairs in buckets. Now my research topic is like let's come to my research topic. My research is on high chromium cast iron (HCCI). So I have taken this material for my research, considering the welding, considering this as my welding filler. Now for this I am we are planning for having a titanium alloy too, which can be added to HCCI. Now, for this, 5 sample is can be prepared with increase in 1% of titanium. Increase in 1% of titanium for every samples. So moving on, this can be done by melting and sintering. Now, two metals can be heated up and can be combined and created a sample which can be used for testing and other purposes. Now melting and sintering has to be done 7 times in this process is because of to prevent formation of heterogeneous mixtures. So if heterogeneous mixtures is formed, they will have a lot of cracks and stuff which can be avoided if we do at least for 7 times. Now tests which are planned to be conducted over this sample is like impact test. Now what happens with the impact is like the bucket is on constant impact with the soil. So there is an impact which happens over here, and for that we can do tests like Charpy test where the sample can be placed under a specimen and a rocker arm with the carbide tip can swing by to understand the impact it can withstand. Now hardness like the hardness can be given to the metal because the impact is so high that it needs to be hardened and has to withstand those load and have abrasive wear resistance. Now to understand the tensile strength of the material, we can have the sample placed in an UTM, that universal testing machine, which keeps on pulling the metal unless it is cracked, unless there is a formation of a crack or there is a formation of a bend or notch. So this gives you the amount of tensile strength and can be taken by those materials. Now durability is, as we said, is a very key features, and for that abrasive wear test can be done. So there is a test called dry sand rubber test. Now what does dry sand rubber test? What can be done is in the specimen can be kept under a rotatory sand wheel, which keeps on rubbing with the specimen. What it can be done is like the industry is working as it's working 24/7 and 365 days. This test can be conducted for one whole day, that is 24 hours, by keep on rotating it, and then by judging the material wear resistance. So thank you. This is end of my presentation. Thank you. How much?